For as long as we've been human, we've stared at the stars and wondered, how far does it all go? And to answer that, we've built these incredible machines, right? Like the James Webb Space Telescope. We've pushed glass and metal and sensors to their absolute physical limits. But there's always been this wall, a point where the faint, ancient light from the dawn of time just gets lost, drowned out in a sea of cosmic static. But what if the next great leap forward wasn't about building a bigger mirror? What if it wasn't about more sensitive hardware at all? Well, that's exactly what's happening. We're seeing a seismic shift, a revolution that's not being forged in a foundry, but coded in a lab by a team of researchers in China, and it's changing everything. So let's get into it. Okay, so to really get why this is such a huge deal, you first have to understand the number one enemy of every astronomer on the planet. It's called the noise barrier. It's this fundamental limit when you're trying to see the very first galaxies, because you're in a constant battle with cosmic interference. Think of it like trying to hear a single perfect whisper in the middle of a screaming rock concert. The signal, that's the whisper. It's these few precious photons of light that have traveled for 13 billion years just to reach our telescope. But the noise, that's the concert. It's a deafening roar of heat from the telescope itself, electronic glitches, atmospheric glow. The signal is almost impossibly faint, and the noise is just overwhelming. Now, the old school way to deal with this was, well, it was kind of brute force. It's called stacking. You basically take hundreds of these noisy photos and just layer them on top of each other. The hope is that all the random noise will average itself out and the tiny, consistent signal will start to peek through. And hey, it works, to a point. But it's a messy approach that loses the faintest, most important details in the wash. And this is where everything changes. A team at China's incredible Tsinghua University looked at this problem and thought, what if we stopped trying to just shout over the noise? What if we could teach a machine to understand the noise and intelligently remove it? They decided to fight the problem now with better hardware, but with a superior mind. They call it ASTERIS. I know, it's a mouthful, but what it does is pure genius. It's an AI model designed from the ground up to do one thing: find the truth hidden underneath all that cosmic noise. This isn't just a filter, it's a whole new way of seeing the universe. So let's put these two head to head. The old way, stacking, just treats a picture as a flat 2D thing. But ASTERIS, it's smarter. It sees the data in 4 dimensions, the 3 dimensions of space plus time. It watches how the noise behaves over a whole sequence of images, learns its specific signature, and then it surgically removes it, revealing what the universe actually looks like. And here's the really clever part. The AI is self-supervised. I mean, think about it. How do you teach an AI what a perfect noise-free galaxy looks like if you've never been able to see one yourself, right? Well, with ASTERIS, you don't have to. It's smart enough to look at a whole mess of noisy images and figure out for itself what's real and what's just interference. It literally teaches itself to find the signal in the static. All right, that's the how. But what about the what? What did this new approach actually deliver in the real world? Well, the results aren't just a little better, they are a staggering, jaw-dropping leap forward. In the world of astronomy, the gold standard for seeing faint stuff is called magnitude. It's basically a score for how faint of an object you can spot. A bigger number means you can see dimmer, more distant things. And this is where ASTERIS just blows the doors off. Specifically, it delivered a gain of 1.0 magnitude. Now I know, the number 1 doesn't sound very dramatic, but you have to understand, in astronomy, gaining a single full point of magnitude is a monster achievement. It's the kind of thing that usually takes decades of work and a whole new observatory to pull off. Gaining 1 magnitude isn't a small step, it's a jump to a whole new level. It means we can suddenly see an entire class of cosmic objects that were always there, but were completely invisible to us before, hiding just beneath that floor of noise. Let's put a different number on it. This means we can now see objects that are 2.5 times fainter than what was possible before. Just imagine your own eyesight suddenly becoming 2.5 times more powerful overnight. That is what this AI just did for our most advanced telescopes. And this is where the story gets truly mind-blowing. To get that same one magnitude gain the old-fashioned way, building a bigger telescope, you're talking billions of dollars and decades of design and construction. The team at Tsinghua, they achieved the exact same result with software, with code, in a matter of months. This isn't just an improvement, it's a complete change in the rules of the game. And this is not just a theoretical exercise. The team immediately took their powerful new tool and aimed it at one of the biggest prizes in science, real-world data from the James Webb, looking back at the very beginning of the universe. And what they found is literally redrawing our map of cosmic history. In one go, ASTERIS pulled out over 160 new candidate galaxies from the cosmic dawn, that period just a few 100 million years after the Big Bang. These aren't just faint smudges, these are the baby pictures of the universe, the blueprints for everything that came later, including our own Milky Way. And get this, it tripled the number of discoveries. They didn't build a new telescope, they just looked at the exact same data in a smarter way. They got 3 times the science out of it. That is an absolutely unbelievable return on investment, and it immediately puts our theories about the early universe to the test. And, you don't have to take my word for it. This work was so groundbreaking, it was published in the journal Science, which is like the Mount Everest of scientific publications. One reviewer put it simply, saying, "This will have an important impact across astronomy." That's the scientific community's way of saying, okay, yeah, this changes everything. So let's zoom out and just think about what this means for the future. We are clearly turning a corner into a new era of AI-driven science, and this breakthrough puts China right at the forefront of that revolution. And the most powerful thing about ASTERIS is that it's not a one-trick pony, it's a universal tool. You can apply it to data from ground-based telescopes like Subaru in Hawaii or space telescopes like Webb. It helps us see deeper into different kinds of light, to peer right through the cosmic dust that used to block our view. It makes every telescope better. This means we can now aim this new power at the biggest, baddest mysteries in the universe. Things like dark energy and dark matter, the hunt for another Earth out there, finding a world that could actually support life. All of these profound questions rely on spotting the faintest possible signals, and we just got a much, much better magnifying glass. So just think about that for a second. We've watched a fundamental limit in science get completely shattered, and it wasn't done with a bigger piece of glass, but with a more elegant piece of code. The old rules of discovery have been totally rewritten. It just leaves you with one really exciting question. Now that AI is in the driver's seat, what cosmic mystery is going to be the first one to fall?